Good day everyone, kamusta? I am Kananyan and welcome to my YouTube channel. So it is your idol engineer back at it again with another video. For today's video, I have a school project. So this school project is called a water level indicator or sensor, which I will make a water level sensor without any microcontrollers. So how do I do that? Of course, I need transistors. It's all about transistors. So let's go! So this is the whole circuit of the transistor only. So this is the whole circuit of the transistor only water level indicator or water level sensor. As you can see, I do have a 2N3904 transistor which have a base current of 5 milliamps and a collector current of up to 200 milliamperes. So as you can see here, these have I have about 7 levels of here. Actually, it's actually 8 plus this one. So the first 7 levels is actually a different color of LED, as you can see here. So this is the circuit of the actual um, this is the circuit of the actual single transistor itself. As you can see here, this is the transistor, this is the uh, resistor for the base, we have a resistor for the load and the load itself, which is the LED, and also we have probes. Probes is actually only what I use here is actually the uh, jumper wire itself and also in the probe base. So as you can see, it has different colors as you can tell in the actual our actual thing itself. This is actual resistor. It has different it has different it has different colors, and the final one is actually the blue one, which is the brightest one and has the biggest needed of voltage. So as you can see, it's 220 over here, and my power is actually 9 volts with a which is in a here. This is the connector, which is, I think it was a terminal block. Then the other one is actually this one. So this one right here, as you can see, is a NOT logic, which inverts the logic itself. So if this is turned on, then the whole circuit is turned off, and if this is turned off, the whole circuit is turned on. So this circuit right here, the main load is actually a blinker circuit, but only transistors, which blinks the LED and beeps the buzzer simultaneously, which is the first level of it. So if the container is not full or there is no water at all, this would blink and buzz simultaneously. But this will buzz not continuously, but rather on a there is a it's a blinking buzzer, I think. What I don't know what is it called, but this is the whole circuit itself. This is actually a 100 microfarad capacitor. I'm sorry for and that. So as you can see, this is the first level, which is this is the first probe, which is also connected to the whole circuit itself. So I also have another other one, which is a what would I say, rather optional because it is not needed, which is the fill the pump itself, which is the drainage system of the circuits. So I did include a drainage system because according to the project description, I do need to have some sort of drainage system because it should be not messy at all. So what my classmates do is just drain, but what I do is drain and fill. So as you can see here, so there is a fill button and drain button, so that it would, when I press this, it would fill the container itself that has probes, and the drain is taking out uh, all the water in the actual on the container that has probes in it. So the container with the sensor in it. So this is the whole circuit of itself. So how it works is this is the common probe, then this is the probe. So if this is the first level, same as to this not logic circuit, which is actually they are on the same level at each other. So if this got water, this would turn off, which indicates the actual circuit has water. So if this turn off, this would not blink at all. Then, and the second level, this is the second level, this would be shorted. This would be shorted to each other, which makes it to turn on because there is a current to the base. And because of that, the LED will turn on, and so on and so forth up to the maximum level, which depends on if the water itself touch the probe. So that's how it works. So as you can see, this is the printed circuit board. As you can see, I only did a one layer PCB because this is a DIY PCB, and as you can see, it is only one layer as it is also single-sided. So this is the whole circuit of it. I will include this on my GitHub page, and I will provide a link in the description below, so you can probably follow this or make this at your home as a project, or if you need any project itself, you can do this. And this is the complete itself, and I will provide a actual picture of the PCB itself. Spoiler alert, it is a little bit messy. Hello everyone, it's Kananian Engineering and welcome. So today we are working on a project. This is a school project, which is a water level sensor, but not an ordinarily water level sensor, but using transistors. As you can see, this is my DIY PCB here, my breadboard, and my tools, which is in the floors. So what I'm gonna do right now is solder the components, these components here, and yeah, let's go. So this is it working. So as you can hear, this thing is buzzing and with no water, as you can see here. If the probe is not touching, it is actually blinking. So if there is no water, it is actually blinking, and if there is any water, it will stop. See, it will stop. See, and also if it's full, as you can see here, so the probe here is red for full. Hold on. As you can see, and that's all the functionality. So if it's empty, this will blink, this would be pulsate, and if it's full, this will continuously buzz, and it would be all, this would be all turn on. So what I'm gonna do is, first I'm going to remove this so I could, as you can see, it's blinking. And then also, this is the main probe. This is tap water, by the way, and let's probe it. As you can see, there is no light because it is connected to each other. So it is basically a NOT gate, and if it's full, look, if it's full, if all the probes are connected, it would be buzzing. So that is the functionality of it. So that is my project that I will going to do today. As you can see, it is right now 7, and the deadline of this is in 11, so I only have 4 days. Yeah, so yeah.